So here we've got a cycle. So first we undergo compression from from a pressure and a volume to another one. So if we draw this here on a pressure volume plot, so we start off at, and so PV is constant. So first of all, I'm just going to convert these units. So it's 10 pounds per inch squared times 4.4482 newtons per pound times 12 inches per foot times 1 foot per, so that's squared, 0.3048 meters squared. So this comes out to 68947.238 pascals. And our pressure 2 is 344,736.189 pascals. Yeah, okay. Okay, so then, and our volumes, our V1 is 4.0 feet cubed times our foot conversion here, which is 0.1133 meters cubed. So our second volume then, so PV is constant, so P1 V1 equals P2 V2. So then 68947.238 pascals times 0.1133 meters cubed over our second pressure, 344, is equal to our second volume. So our V2 is 0.0227 meters cubed. Okay. So now we've gone from a larger volume and a smaller pressure to a larger pressure and a smaller volume. And then so we're compressing, and then we're going from we're maintaining the pressure to bring the volume down, and then we're going back maintaining the pressure. So constant volume here, but changing the pressure, and then bringing the pressure of the volume back under constant pressure. So here is constant volume, and here is constant pressure. There. Okay, so then for this first one, our work, so our work is always minus P dV. So our PV is a constant, or our pressure is our constant over V. I'm going to go ahead and just call this constant C, so I just don't have to write C all the time. So C over V. So our work is minus C dV over V. So then our work is the integral of this expression, so minus C integral of dV over V from V1 to V2. So minus C ln V from V1 to V2, which is minus C ln of V2 minus ln V1. Which from ln rules we can write as minus C ln V2 over V1. And again, using ln rules, so negative of a ln, you can just flip them. So it's just C ln V1 over V2. Now the value for C, we can just use our P1 V1. And write it like that. As our C, we could use really any pressure volume. So we could have used P2 V2, but might as well just use those. And so then it's 6, 8, 9, 4, 7, 2, 3, 8 pascals times our initial volume times the ln of our initial volume over our final volume, which comes out to be 12,558.704 joules. So there's our work in that compression. So that's 1 to 2. So for 2 to 3, dV equals 0, as we're under constant volume. So our work is 0. And then for 3 to 1, we're under constant pressure. And that pressure is our initial pressure. Wait. Did I not convert P2 right? Oh yeah, okay. Ugh. Is our initial pressure. So that's the so our work is minus P delta V, which is our minus 68947.238 pascals. Our delta V is 33 meters cubed minus 0.0227. So that's our final minus our initial. So that's minus 6,246.62 joules. And then, so that's the work done in each process. And then our total work is 12,558. So there's our total work done. Okay, so checking through the solution here. Oh, they left everything in pounds and feet. So I can really just say, looking at the expressions, so there's our constant temperature work. So that is the same expression as if PV is constant. Then it would either be P2 over P1 or V1 over V2, which is what we used. The work in the second process is 0. And then in the third process, we just have PV work. Now this should be minus PV, not positive, so it actually wouldn't sum up. So work in third process should be negative. So or should it? No, because it's expanding. No, that's not correct. My bad there. Yeah, it shouldn't freely expand, so that actually might be my bad there. Work. This is it should be minus P delta V, or is it actually just P delta V? Ugh, I've got myself confused here. So the work. So delta U should be minus F dx, which is minus our force over our area, which is our pressure, times our dV, so minus P dV. Right, okay, my apologies. So the work should be minus delta U, so it should be plus, sorry. So that would be plus. And then this would be the sum of those two. So yeah, so that's right. So it should be plus P delta V. So that does look good then. Just some unit stuff. Okay.